Hello, it's Ms. Hall,
And Miss Nelson.
and we're doing simple events, probability of simple events. So, probability. I don't have the definition of that, do you?
So we can make one up.
Yeah.
Okay, so what probability is? Probability is the likelihood an event will occur. Okay, and this can be with anything. It can be with a deck of cards like we've already talked about. It can be with dice, spinners. There are a lot of certain situations that will come into play for finding the probability of certain events. And remember, most of the time we talk about them in fractions, but they can also be in percents as well.
So she led into our next fill in the blank. It says probability are most often represented as fractions in their simplest form. You may also be asked to represent probabilities as percents. Okay. Forms for asking probability. What is the probability of green? I'm just using an example. That's how we would say it in a number sentence, but you will see it written P and then in parentheses green.
So anything in the parentheses is what you're actually finding the probability of. Okay, so sample space. Sample space is all the possible outcomes. Okay, now there are several ways that you can write your sample spaces. And these are the three most traditional ways that you see them. It can be in a tree diagram, and you guys have been seeing this for several years now. It's just kind of words that branch off to other words. It can be in a table or in brackets. Okay, now brackets are not parentheses, so don't think that they are parentheses. They're kind of, Ms. Hall and I kind of call them the fancy parentheses. They're kind of scrolly, but they are in fact brackets, so call them brackets and not parentheses.
And I can't do them very well. That's my best effort there, guys. Sorry. They'll look all different kind of ways with me. So anyway.
Okay, so what we are working on, we are going to be writing the sample space of what it would be. So for all the possible outcomes, okay, of this spinner, and literally all you're going to do is just call out all the colors. So purple, blue, yellow, green, and red. And it can be written in any order. It doesn't have to be in a specific order. But those are all the possible outcomes.
And my pretty brackets that you see there. So 1, 2, 3, 4, 5. I made sure I had all 5 of them in there. So so I have possible outcomes. We have a total of 5 possible outcomes.
And you wouldn't really use a tree diagram and really even a table to show this situation specifically because we're only talking about the possible outcomes. We're not asking for a specific event to occur. So if you just want all the possible outcomes, you put it in the brackets. If you want to show how often a specific event will occur, then you are going to use a tree or a table. Okay, so example B, tossing a coin 3 times. Okay, so I'm going to do a tree diagram to show you the possible outcomes.
I'm just going to get out of the way because it's kind of real big. Sorry.
Okay, so we know if we toss a coin, our first outcomes are going to be heads or tails. Okay, now if I toss each one of those again, I still have the same outcomes, but you see we're starting to branch off. Heads and tails. Heads and tails. And now each one of those is going to branch off as well. So you see that each time we do it, the outcomes that we are going to get become greater as we get a little bit further. So we have 8 possible outcomes. Where do you get your 8 outcomes from? I wanted 3 times, okay? And so because I wanted 3 times, you check the very end of your tree, the very side or the very bottom, depending on how you want it, because this was time 1, this was time 2, and that was time 3. So I want to look at time 3. So all of our possible outcomes we know that we have 8 possible outcomes from counting them. Mathematically, what I can do is, if I look at my first time I flip a coin, I have 2 outcomes. The second time I flip a coin, I have 2 outcomes. And the third time I flip a coin, you have 2 outcomes. So 2 times 2 is 4, times 2 is your 8. That 8 matches that 8 that we wrote just from our tree diagram.
Okay, so as the number of attempts increases, the experimental and theoretical probabilities should become closer in value. Now what that means is, it's not on here, but your experimental probability is what actually happens.
And we've talked about this previously in your foldable. Remember, it's what actually happens. You do not have to do the experiment, but an experiment was done.
And the theoretical is what should happen.
Remember, that's your perfect world scenario. So that was like the deck of cards that we did in class today. What you should get out of that deck of cards.
So what they're saying is if like your heads or tails, it's a 1/2. In theory, 1 out of every 2 times you toss, you'll get heads or tails. But if you just do the experimental maybe 10 times, you only got heads 3 and tails 7. But if you did it 1,000 times, that 1/2 is going to become closer to close in value. Instead of 3 out of 10, it would be closer to 1/2.
Correct.
Okay, if you have any questions, come tomorrow.